This is a video on using implicit differentiation to find the equation of a tangent line. The question states, find the equation of the tangent line to the graph of 14 minus 3xy plus 4y over x equals x at the point 2, 3. Since the function is defined implicitly, I'll use implicit differentiation to solve this, which means I take d over dx of both sides. So the derivative of 14 with respect to x is just 0. And for the derivative of negative 3xy, I need the product rule. The product rule says that I take the first, which is negative 3x, times the derivative of the second, which is the derivative of y, or y prime, and then plus the derivative of the first, the derivative of negative 3x is negative 3 times the second, which is y. And then I take the derivative of 4y over x. I use the quotient rule for that since I have a division. So the quotient rule says low, which is x, times d high, the derivative of 4y is 4y prime, minus high, which is 4y, times d low, the derivative of x is just 1, and then square the bottom, x squared, and away I go. So then I take the derivative of x for the right-hand side, which is just 1. At this point, I could solve for y prime, but that would be really tough. Instead, there's an easier way. I have the point 2, 3, so I can let x equal 2 and y equals 3 and plug in right away. And I do that, and I get 3 times 2 times y prime minus 3 times 3 plus 2 times 4y prime minus 4 times 3 times 1 divided by 2 squared. And that's equal to 1. So now I perform the arithmetic. Negative 3 times 2 is negative 6. Negative 3 times 3 is negative 9. 2 times 4 is 8. And 4 times 3 times 1 is 12. So I have an 8y prime minus 12 over 4. I can divide the 8 by 4 and the 12 by 4 and simplify. And I get negative 6y prime minus 9. 8 divided by 4 is 2, so I get plus 2y prime. And 12 divided by 4 is 3, and I get minus 3 equals 1. So now I can add the negative 6y prime and the 2y prime to get negative 4y prime. And I can also see I have a minus 9 minus 3, which is negative 12, and add 12 to both sides to get 13. So I get negative 4y prime equals 13. And now to get the derivative, I just divide by negative 4. And I get y prime equals negative 13 fourths. There's my derivative, which is the slope of the tangent line. Let's find the equation using the point-slope formula. There's my point 2, 3, and my slope, negative 13 over 4. So I get y minus y1, or y minus 3, equals m, which is negative 13 fourths, times x minus x1, or x minus 2. And now I just clean this up. I multiply the negative 13 fourths through. Notice negative 13 fourths times negative 2 is 13 halves. And 13 halves plus 3 is 13 halves plus 6 halves, which is 19 halves. So my final answer is that the slope, the equation of the tangent line is y is equal to negative 13 fourths x plus 19 halves. And I'm done with the problem.